Okay, just wanted to make a video to help walk you through this Google Sheets assignment. So it used to be that we were able to copy and paste the data right from a Google Sheets document, but it looks like Google Sheets has changed the way its permission rules work. So in order to get your data this week, you're going to have to visit this link. So I'm going to copy it and paste it up here. And that allows me to download the CSV file. Okay, you don't have to wait for all this to load. You can just click download. And there it is. And you could open it up in Microsoft Excel if you want. Or what I'm going to do is I like to have everything in Google Sheets online. That way I save my edits. I don't lose the information in case my computer doesn't work. I'm going to Google search Google Sheets. Just like we usually do. Go to Google Sheets. And then you can... Oh, it's going to log me in. So that's... Let me change accounts. This is my fake fake email account. Oh. Okay, so get yourself a Google Sheets document opened up. And then we're going to go to File, Open, and then you just have to open up that file that you just downloaded. So if you go to Upload, you can click and drag it if you're using Google Chrome, or you can find it in your file system on your computer. Just open it. It's usually in your Downloads folder. Just do that File, Open, and then upload the CSV file that you just downloaded. And if you have trouble with that, let me know and I can see what I can do to help you out. So once we have the data in the Google Sheet, you're going to see some information that you're just going to want to check out about the requirements of a confidence interval. And the first thing we're going to do is, like we do with a lot of these things, we're going to randomize the data. So column I, I'm typing equals. Try to zoom in here. Sorry, the zoom's not working so good. Okay, so type equals, rand, open a parentheses, close a parentheses. That probably feels pretty familiar, huh? And hit enter, and there's a random number. And then we want to randomize all the numbers, so we're going to click and drag. So now every row has a random number assigned to it. So to finish randomizing, we're going to right click the top row, and then we're going to say sort sheet A to Z. So there, now we have some random numbers. So that's basically what this whole first part is about. And now to check those conditions, the first thing we should do is we should make a histogram. And the key data here, actually, if you want, you can delete G, F, and E. These are just some pieces of information about the schools. I mean, you can even delete this. You can delete this. That's just the school code. That's just information that might be interesting in case you're wondering about the particular schools. Column H is the column we're going to be using for this Google Sheets assignment. Okay, so the first task is to look at histogram of column H. So click letter H to highlight it. Then go to Insert, and then Chart. And then we don't want a line chart. We want to click that so that we can scroll down and find histogram, which is right here. There's a histogram. So you should have a histogram that looks exactly the same. Okay, it's somewhat non-normal. I'd say skewed left a bit. And we don't need this column. We're just doing column H. So that's the first part. You need to make that histogram and include it. So part 2 is where we actually start constructing the confidence interval. So the first thing we're going to need is the mean and the standard deviation. So off to the side. Oops, I'm in the wrong file here. So in your data file, I'm going to write the word mean and standard deviation, just so I have those. Let me think here. Yeah, I guess that's everything. And remember, when you read through the file, it's going to mention this. We're only doing it for the first 12 numbers in your randomized list. So I'm going to type equals average, open a parentheses, and click and drag for the first 12 numbers. and then I'm going to close the parentheses. So remember, we're constructing a confidence interval. So here's our sample mean. And in order to construct the confidence interval, we're going to need the sample standard deviation. So I'm going to write stdev.s, like we've done before. Open the parentheses, click and drag, close the parentheses. And then I think that's it for the first steps. That's what's demonstrated here in these pictures. And then Google Sheets or Excel, Microsoft Excel, depending on what you're using, can also get us the margin of error. And this is a new function to us this week. Type in equals confidence.t, open a parentheses, and then it's going to want alpha first. So we're constructing a 90% confidence interval. That means our alpha is 0.1. So let me back up so you can see me typing it in. So I put 0.1 in for alpha. Then I'm going to put a comma. And then my standard deviation is right above, 14.24. 2 decimal places is fine. Then put a comma. And then size is the sample size. So there's 12 data points. So we're going to put 12 in there for the sample size. Then hit enter. And there's your margin of error. So the confidence interval has a lower bound and an upper bound, right? A lower number and a higher number. We take the mean and we subtract it by the margin of error to find the lower bound. So the lower bound for my confidence interval is 1122.29. Yours will be different because you have different randomized numbers. And then the upper bound is going to be the mean plus the margin of error. So my upper bound is 1137.05. So that's part 3. Okay? We've got our confidence interval. I just demonstrated all the steps that are discussed there. Sorry, part 2 I should say. I listed the wrong number. That's the next part. That's part 2. Part 3, I'll change this so that it says this is part 3. Part 3 is where you repeat this process 9 more times. We have to have 10 in total, okay? And the reason we have 10 is so that we can see the 90% being demonstrated. A confidence interval set of 90% means that 90% of our confidence intervals are going to have the population mean inside of it. So that's why I chose 90%, and that's why I chose 10. Because if we use any lower confidence interval, like 80%, 75%, just getting less and less significant, and it's starting to turn into, you might as well predict it with a coin flip. So I know that sounds like a lot. Let me demonstrate how I would do it right here. That way you can see that it's not too bad, doesn't take too long, and you can finish seeing all the steps. So you could do this on paper, but I've got a notepad document opened up. The reason why we got to do this is because when you randomize the numbers, these are all going to get shifted around. So every time you're going to have to, you're going to have to jot down your confidence interval off to the side somewhere on paper. So got my first confidence interval, need 9 more. So you're actually going to have to sadly delete this unless we go into more in depth with Google Sheets on how to freeze items. But got to repeat the process. Okay. So select your random number column, right click it, and then sort it from A to Z. So now we have a new randomization, and we want to start from the top again. We want to calculate the mean. So type equals average, and we want only the first 12 numbers. So I'm going to highlight those 12 numbers. So I've got my mean. I need my standard deviation. So type equals stdev.s, open parentheses, click and drag for the 12 numbers. And then we're ready for the margin of error. Remember that's the new command this week. Type equals confidence.t, open a parentheses, and then we're going to type in 0.1 for alpha. Now a new standard deviation this time is 24.44. The sample size is 12. And so now we're ready for the lower and upper bound. So the lower bound would be the mean subtracted by the margin of error. So 1108.16 is our lower bound, and then take the mean and add the margin of error. Oh, it's 12.27. So that's my upper bound. Okay, so there's my second confidence interval I'm going to write down on a piece of paper or off to the side on a computer. So we just need 8 more of those. Okay, I'll go through the steps kind of quickly here. I want to randomize again. It's just repeating the same stuff. We need the mean. So that means it's only for the first 12 in our randomized list. We need a standard deviation. The first 12 numbers. And then that gives us enough information for the margin of error, which equals confidence dot t, open parentheses. The alpha is 0.1, standard deviation this time is 19.3, and then the sample size is 12. And so the lower bound is my mean, my sample mean of 1121.83 subtracted by my margin of error. My upper bound there we go. My upper bound is my mean plus my margin of error. So there's my next confidence interval. So we got to do that again. Need a mean. Oh, sorry, we need to randomize the data first. So I need a mean, which is equals average, H1 to H12. Need a standard deviation, which is equals stdv.s. Click and drag, close the parentheses, and then we need a confidence interval, so we need a margin of error. We get that from equals confidence.t. Alpha is always 0.1. Standard deviation, that changes every time you take a new random sample, and then the sample size is 12. So the lower bound is found by taking the sample mean and then subtracting a margin of error from it. So I'm just going to write it right in here. And then we add a margin of error to the sample mean. So there's my next confidence interval. And so obviously you can make this stuff go a little bit faster. You don't have to type. You don't have to keep typing in. Actually, the mean and the standard deviation you want to keep. The margin of error. Once you know that, maybe we can make it a little quicker with our, with our calculator. So we've got 4. So I need a mean. Oh, I need to randomize the data again, so I don't have the same confidence interval. So I need a mean. This is H1 to H12 every time. Standard deviation. H1 to H12. And now the confidence interval equals confidence.t. This will give us the margin of error. Different standard deviation this time. And so that's going to be the margin of error for the confidence interval. We just take the mean, subtract the margin of error from it. We take that sample mean again, 1129.92, and we add margin of error to it. So I'm halfway done. Just make sure to randomize every time, right? So the mean, that's equals average, and it's H1 colon H12 every time. And so the margin of error is equals confidence.t 0.1, standard deviation 12. So now we're ready to calculate the lower bound. The lower bound is just the mean subtracted by the margin of error, and then it's the mean plus the margin of error. randomize the data again, so that means that's gonna be gone. Standard deviation, confidence interval equals confidence dot t, and then 0.1, 20.36 for the standard deviation, and then a sample size of 12. So my new confidence interval, 125.58 subtracted by 10.56. That's my lower bound, and then my upper bound. There we go. 1, 2, 3, 4, 5, 6, 7. Almost done. Just 3 more. Randomize the data. Mean is equals average, the first 12. Standard deviation. We use the sample standard deviation. Confidence interval is 0.1. Standard deviation 12.97. And then we've got sample size of 12. So remember, the lower bound is the mean, subtracted by that margin of error you just calculated. And the upper bound is the mean plus the margin of error. So there's our 8th one. Oh, I didn't randomize my numbers. Randomize that column. And the mean is going to be average H1 to H12. Standard deviation is equals STDV dot S, H1 to H12. And then we want equals confidence dot T, and 0.1 for alpha, 19.91 for the standard deviation, 12 for the sample size. So we take away one standard deviation, and then we add a standard deviation. Oops. Last one. Now I gotta randomize the numbers. There we go. The mean, so I'm going to be typing in equals average, H1 to H12. Standard deviation equals STDV.S. You're never going to forget these commands after this one, are you? And then the confidence interval equals confidence.t, 0.1 for alpha, standard deviation 29.64 this time, and then sample size of 12. So our confidence interval is the mean subtracted by the margin of error for the lower bound. The upper bound is the mean plus the margin of error. Okay, so it wasn't to torture anybody, right? That's obviously a lot of like repeating steps, and the whole reason we're doing that is so that we can see the big end here. Confidence intervals mean 90% of our confidence intervals should contain this. That means one of these we would expect would not have 1126 in it. Okay, and that's not always going to shake out in practice. Just like when we did expected value in the course, expected value is how much you expect to win or lose on a game if you keep doing it many times. So 1126, that's between these two numbers. It's between these two, between these two, between these two. It was almost cut off in this one, but it is between those two, those. So actually for mine, all 10 of my confidence intervals captured the mean. Okay, and that might be the same for you. Some of the classmates are probably going to have a couple, are going to have 2 confidence intervals that don't have the mean. That's okay. That's just statistics, right? Most of the time, though, there's going to be 1 out of these 10 that does not contain the true population mean. So that's the big point of the Google Sheets assignment. I know I can type a lot faster than the average person, so I'm not expecting you to get done the Google Sheets assignment this quickly, but just wanted to show you that I feel your pain for having to calculate all 10 of those, but just want to reinforce there's a reason for it, right? If you're to do this 100 times, then 10 out of the 100 would not actually have the population mean. 10 out of 100 would have an error.